Thank you. So I'm Jonathan Barcroft from National Grid Electricity System Operator. I'm part of the innovation team and responsible for the common framework work stream on the Virtual Energy System programme. Over the next few minutes, we're going to share an overview of our programme and a summary of our recent design outputs. So the energy system is changing. Achieving net zero requires the development and operation of an integrated whole energy system across many vectors, including electricity, gas, heat, and hydrogen. Operating this integrated energy system, where many thousands of assets are responding to variable and dynamic signals, requires modelling of a wide range of scenarios. Defining and modelling those scenarios requires visibility of system behaviour, whether that's network assets, generation, storage, or consumption. To get this visibility in a decentralized energy system operated by many different organizations requires data sharing. And this data sharing needs to be supported by a common socio-technical framework to facilitate interoperability. Continuing the cycle, we can therefore conclude that achieving this net zero in this integrated energy system requires the development of that socio-technical framework for data sharing. To support the delivery of this, I'm introducing the Virtual Energy System. It's an ambitious whole energy system programme to enable the development of an ecosystem of connected digital twins, representing the entire GB energy system to help solve wider system challenges. These could include energy optimisation, carbon reporting, investment planning to help develop that future net zero system. In the Virtual Energy System, we've proposed the common framework, 14 areas of focus, representing both the social and technical factors that we believe are needed to support this ecosystem. Starting with the data, to make it easier to understand and use, we need to align models and taxonomies using common data exchange standards. We need to increase visibility and sharing, making it both findable and accessible. In process, we need to engage with experts across the sector and beyond, as this is not a mission that can be achieved alone. We need to develop a governance model that sets out the decision-making process to facilitate collaboration and participation. To create this ecosystem through collaboration includes defining roles and forming a shared culture under people. And underpinning all of this is technology. To create connections will be dependent on an interoperable tech stack, which can be adopted in a range of different environments and organisations. In August this year, we published our initial high-level designs for the first 6 factors, which you can find on our programme website, which we'll share later. And following these, we've also started considering managing security, where we'll examine the required security controls and determining the operating environments, which will review the business and operating models to ensure that the virtual energy system is economically sustainable and supports adoption, while we continue to develop the designs for the initial 6. Through our examination of user journeys and operational planning, we've considered the activities of a data provider, for example, a distribution network, sharing their data with a data consumer, for example, the transmission system operator or a neighbouring network. We consider that user journey to have 6 steps. They're split between being performed by the data provider and the data consumer, and we'll walk through those now. The first 2 steps are performed by the data provider. These are to prepare and publish their data. In this case, we use the example of that distribution network. It starts with data in an internal model system, and it's normally in local or proprietary formats, purposely designed to suit their own business and user needs. To be used by others across the sector and beyond, this needs to be standardised into an agreed energy sector format. In our current phase, we're evaluating the application of Common Information Model. This may depend on specific use cases, as some data products may not be supported or may be better supported by other standards. This standardized data is then populated with metadata, likely using the Dublin Core standards, and is tagged with security controls to ensure that it's only shared with its intended audience. A key stage before the data is shared into the ecosystem is ensuring that it's validated through schema validation as conforming to those agreed standards. The precise mechanism for that is currently under consideration. The data is then shared using APIs that can connect machine to machine, and the interface is listed to users. Our focus then shifts to the data consumer for the second 2 steps. The data consumer is looking for data to tackle their use case. They search for that data through a data portal on which the available interfaces have been registered. The metadata provided by the data provider is used to make this searchable across participants in the ecosystem. The next step depends on the sensitivity of the data being shared and the decisions of the data provider as to who can access it. For open data, the data consumer will be able to use the information defining that API to connect to it. For shared data, the data consumer will then have to follow one of two routes. They'll either be pre-approved because their user properties align to the conditions that were set out by the data provider, or they'll need to request access. If they're pre-approved, they'll be able to immediately use the information defining that API to connect. But if they're not pre-approved, they'll need to request permission before they can be given access. When the data consumer requests access to the data provider will be notified. They can then review that access request and decide whether to approve it. At this stage, there may be additional activities that go on, such as contractual agreements or payment. If the data provider approves the request, the data will then be shared through those APIs or via additional services for streaming and consumed machine to machine. As part of this process, security access and governance controls will be applied within the ecosystem, and approved protocols will be used for connections. Bringing these stages of the user journey together, we reach our proposed high-level design for the data sharing infrastructure. This consists of the prepare stage on the left-hand side of the diagram, where the data is transformed into agreed industry standards before being validated for conformance with those standards. The block in the middle of the diagram includes functionality for the trusted sharing of data. Additional to the previous slides, there are options for further components that will be considered as use cases develop. These may be supported by services or potentially through additional open source packages. The system is deliberately decentralized, keeping the data providers in control of their shared data and proposing the use of common design standards and minimal common services to facilitate the coordination of the shared components of the ecosystem, such as those data catalogs or the trust framework. In our current phase of work, we're considering the components required to achieve the minimum viable product and assessing their technical maturity. On the right-hand side, you can see the data consumer uses a reverse process of the data preparation step to consume and then apply it to their use case. So we've published all of the design thinking behind that and the outputs for those reports of that written phase that completed in August on our program website, which will be shared in the meeting chat shortly. And I look forward to catching your questions and any comments that you have in the Slido session. Thank you.
The next question to yourself, Jonathan, is does the energy sector already have agreed standards for data sharing?
So a lot of our existing processes are defined in industry codes, and they use a range of different templates, typically in Excel and Office products. So not a data standard per se, but there has been adoption of the Common Information Model, and there are programs going through from Ofgem through their work on long-term development statements, which are moving the energy sector in that direction.
Thank you. And another question for yourself, Jonathan, is this is really interesting to hear. How does this connect to the National Digital Twin Programme? Is this the energy sector part of it?
Just in the current phase of this project, we've taken that high-level design and we're working through with the National Digital Twin Programme to review the component parts and check for alignment and agree on how best to develop that together.
Good. And another question, so Jonathan, for yourself is, how are you considering the risk of deliberate data poisoning by an adversary who intends to disrupt the energy sector, as they've done in Ukraine? So bad actors in the system. How do you consider and mitigate for that?
It's an element that we're considering in this managing security factor. So it's not something I've got a direct answer to right now, but it's something that we are considering.
Very good, thank you. And the next question, Jonathan, for yourself is, what are the biggest challenges in developing the virtual energy system?
So to date, I would say it's definitely the sheer number of moving parts that are in the energy sector. The complexity of the transformation that we're going through to achieve net zero is being adopted by organisations around energy, new starts, the regulated networks, try and stay on top of exactly what's happening at the moment, trying to get the right people into the rooms and drive that discussion into a sort of converging principle has been one of the biggest challenges to date, but something I think that we're hopefully taking on. And if you do have extra things that we've missed, please do send us a message to help us with that challenge.